Hello, my name is Carolina Mingasarian, and in this video we're going to be doing the geologic timescale activity. The first thing that we should really think about before we even start this activity is the fact that Earth is about 4.6 billion years old. Now you may ask, what is a geologic timescale? A geologic timescale is just a scale of time on Earth which uses different time intervals that hold significance in order to divide Earth's history. This geologic timescale on Earth is actually very organized. It's organized under eons, eras, periods, and epochs. Eons hold the largest amount of geological time and consist of several of hundreds of millions of years. Right after eons, there are eras, which are slightly less significant and smaller, but are still determined by very significant events in history of Earth. After eras come periods, which are a subdivision of eras and are determined by a variety of less significant events as compared to the ones in the eras. Lastly, epochs are subdivisions of periods and are only done for the most recent part of the geological timescale. For this lab, you will need some markers, some cashier's tape, and a ruler. First things first, it's probably best if you recruit a friend for this lab. But secondly, you will have to lay out 4.5 meter long cashier's tape on the floor. Make sure you have plenty of room for the tape, not only just to have the tape there, but also to have enough space to draw and write. The geologic timescale is going to start from right, which is all the way down there, to left, which is all the way down here. So we're going to go backwards this way. The next very important part is to tape the ends of the cashier's tape. That end and that end. Starting all the way on the right, we're going to start marking every 1 meter, which is going to represent 1 billion years. After that, every centimeter is 10 million years, and every millimeter is 1 million years. Starting from the right, I'm going to find a few centimeters and label it today. Using table 1, find all of the major events that have occurred and start labeling them and measuring them out on the piece of paper. After that, just 3 different events that you want to draw. Only 3. Also, make sure to use the right colors for each era. If you followed all of the directions, yours should look something like this. Not exactly, but it should resemble something like this. For me personally, I chose the 3 things to draw to be the earthworms, the ferns, and the jellyfish. The earthworm is part of the Mesozoic era, the fern is part of the Paleozoic era, finally the jellyfish, and the rest of the way over there is part of the Precambrian era. At the very end, when you've labeled everything and measured everything out correctly, find the center and just label it. So at the center of my timeline is somewhere about here, and I'm gonna name it the Geologic Time Scale. And after many long minutes of measuring everything out, you should understand the true scale of what happened on our Earth. Most of the things that we recognize and find familiar are actually located very near to where today is. But our Earth dates back not from the jellyfish, but from all the way down there. Humans are at 0.1 millimeters, which is tiny. It's right here. And dinosaurs are about at the 24 centimeter mark, which is right here. Comparatively, we are brand new creatures. Truly, this scale and this grandness allows us as humans to understand just how long the Earth has been in motion. With the recognition of the previous 5 mass extinctions, putting this all in scale really allows us to understand that if another mass extinction were to come, the 6th one, then it will take millions of years for more species to develop. Thank you for watching the video and participating in this activity. I hope this activity enabled you to understand just how grand the true scale of geological time is on the planet Earth. That we as humans are very new, and the species that we know of and we commonly talk about are brand new as well, even though it took them millions and billions of years to develop. I hope with this knowledge you were able to really comprehend how long ago dinosaurs existed, and that really, if you think about it, dinosaurs are closer to our lifetime than the first bacteria that existed on planet Earth. Thank you for watching, and have a great day.